Alright, this is section 2.4. We talk about the average rate of change, or another word for that is slope. We use the lowercase letter m to indicate slope. There's two ways to look for the slope formula. It's typically y2 minus y1 over x2 minus x1. Or you can do f of b minus f of a over b minus a, either one. Now linear functions have a constant rate of change. For example, if y equals 3x minus 5, we know that the slope is always 3. So 2.4, question 1 says find the average speed if you're traveling 100 miles in 2 hours. So 100 miles over 2 hours is 50 miles per hour. Number 3, the average rate of change of the function f of x equals x squared between 1 and 5. Okay, so you say f of blank equals blank squared, and you plug a 1 in there, so f of 1 equals 1 squared, or 1. F of 5 equals 5 squared, or 25. And so now you got the points 1, 1 and 5, 25, so you can plug them in, and you can use the function notation, and you get 25 minus 1 over 5 minus 1, which gives you 6. Or you can use the y2 minus y1 formula, and you get 25 minus 1 over 5 minus 1, which also gives you 6. The average rate of change between x equals a and x equals b is the slope of the secant line between a f of a and b f of b. The average rate of change of the linear function f of x equals 3x plus 5 is 3, because it's a line. 6a, can the average rate of change of an increasing function ever be negative? No. b, if the average rate of change of a function between x equals a and x equals b is negative, then is the function necessarily decreasing on that interval? No. Because if you look at the average rate of change between a and b, it's decreasing, it's falling. But is it necessarily a decreasing function? No, it's actually increasing and then decreasing. So that's not necessarily true. Question 8. They give you a graph here and they ask you to find the net change between these 2 points. Well, you start at 4 and you drop to 2, so that's a net change of negative 2. And then they ask you to find the slope. Well, you can do rise over run, right? The rise is actually a negative 2, it's falling. And the run is a positive 4. So negative 2 over positive 4 is negative 1/2. Question 11, they give you the function and they ask you to find the net change and the average change between the given variables. So f of t equals 5t plus 3 is f of blank equals 5 blank plus 3. So first they give you 4 and 7. So you plug a 4 in there, 5 times 4 plus 3. Then you plug a 7 in there, 5 times 7 plus 3. And because of these answers, you now get these 2 points, 423 and 738. So the net change between f of 7 and f of 4 is 38 minus 23, or 15. But your actual slope is y2 minus y1, x2 minus x1, 38 minus 23 divided by 7 minus 4, which gives you 15 over 3, or 5. Same idea here. Find the net change and then the average rate of change. So 3 blank minus 4 over 5. So you plug a 2 in there. 3 times 2 minus 4 over 5. 3 times 5 minus 4 over 5. Each one gives you these fractions. So now you got these 2 points here. Now what's the net change between 5 and 2? Well, h of 5 is 11/5. h of 2 is 2/5. So 11/5 minus 2/5 is 9/5. That's your net change. Notice you take the higher x value, subtract the lower x value. And now the slope is just y2 minus y1, x2 minus x1. The only difference is this is complicated because it's a complex fraction. 9/5 over 3, or 3 over 1, is 9/5 times 1 over 3. You take this bottom fraction, flip it, and multiply it. Reduce, you get 3/5. 15, same idea, 3t squared plus t, so 3 blank squared plus blank. Plug a 1 in there, 3 times 1 squared plus 1. Plug a 3 in there. 3 times 3 squared plus 3. Each one gives you an answer. So now you got these 2 points. What is your net change? It's net change. It's 30 minus 4, or 26. What's your slope? 30 minus 4 over 3 minus 1. 19, you got your function f of blank equals 4 times blank squared. So you plug in an a and an a plus h. So plugging in an a, you get 4a squared. Plugging in a plus h, you get 4a plus h squared, which gives you this guy when you multiply it out, and then multiply it by 4, you get that. So now here's our final question. What is this difference quotient? Well, it's the first guy, this guy here, minus the second guy, that 4a squared, all over h. Dropping your brackets, that becomes negative 4a squared, which cancels with positive 4a squared. You just have things with an h in them now. And now when you cancel the h, you get 8a and 4h. Question 20, same idea. F of blank equals 3 times 10 minus, f of blank equals 3 subtract 10 blank squared. So f of a is 3 subtract 10a squared. A plus h is 3 subtract 10a plus h squared, which when you multiply it out and multiply that by the 10, you get this guy. So this guy is your first bracket. This guy is your second bracket. When you drop the brackets, you distribute that negative sign, so that becomes a minus 3 and a positive 10a squared. They both cancel with the others, leaving you with just terms with an h. Notice the 3 and the minus 3, the minus 10a squared and the positive 10a squared, they cancel. So now each one of these cancels with an h, leaving you with minus 20a subtract 10h. Alright, question 29 says a graph shows the depth of water W in a reservoir over a year period, number of days, up to 365 days. So then they say, what was the average rate of change between day 100 and day 200? Well, day 100 it was 75, and day 200 it was 50. So 70, the rate of change is the slope. 50 minus 75 over 200 minus 100. So it dropped by a quarter foot each day. B, find the interval in which the average rate of change is 0. Well, you can go from 200 to 350. That's an average rate of change of 0 because they're both at 50. There's multiple answers here. You could have said 0 to 200. That's both those are at 50 as well. 31, they give you a table of populations and they ask you to do some calculations. They first say, what's the average rate of change between 2008 and 2012? So if you look at the table, you get these two sets of numbers. Then you just do the slope formula. Then they say, what about 2014 to 2018? Again, you get these numbers from the table and you do the slope formula. Then C says, what period is the population increasing? Well, if you look at the table in your ebook, section 2.4, question 431, you'll see it's increasing from 2002 to 2012, and it's decreasing from 2012 to 2020.